to our webinar today. It's pretty exciting. We have Cube and MotherDuck doing our webinar with our speakers, Brian and Tony from Cube and Alex from MotherDuck. But before we get started, I just wanted to go over a few logistic pieces. If you have a question, you can ask us anytime. Just simply click submit. And we'll get that answered during the Q&A portion of the webinar. The recording of the webinar will be available on demand right on our events page after the live show. And if you have any feedback, tell us how we did. Take the survey. I promise it's super quick. And what we'll be discussing today, we'll go over overview of Cube. We'll introduce you to MotherDuck and DuckDB. And then you'll see Cube and MotherDuck in action in our live demo. And then you can ask us any questions you would like during our Q&A portion. And finally, we'll close out with the resources from this webinar. So without further ado, I'm going to pass it off to Brian to get this webinar started. Welcome, Brian.
Hey, everybody. Good morning. My name is Brian Bickle, and I'm the VP of Alliances here at Cube. So, happy to be on the webinar with our partners, Alex from MotherDuck. I'm sure that, probably everybody on this call has heard of MotherDuck and DuckDB by now. There's been a lot of buzz and a lot of excitement about them in the industry. So we're really excited to be here today with them. But first, I'm going to go ahead and start by, kind of recapping what Cube is, if you aren't familiar with Cube, and kind of what we do. Cube is a universal semantic layer. And really what we try to do is we help organizations by making all of their cloud data accessible and consistent to every different use case that they have. And the big thing that we focus on is, enabling them to take the disparate data sources that they have and connect them to these really wide-ranging types of use cases, such as embedded analytics, connecting and harmonizing multiple BI tools, or increasingly serving AI agents. And a lot of those take the shape of like interactive chat applications, and some of the emerging patterns there are things like retrieval augmented generation, which are really interesting. I would say definitely like watch the space. AI agents are something that we're seeing a lot of people use Cube for. That's kind of moving pretty fast right now. But to drill into a little bit more about like the thinking behind Cube and kind of like where we come from and why we built the product and how the company got started. The founding team at Cube started to see this problem of data platforms becoming more and more complicated for most organizations. That expresses itself in this sort of data chaos, as we put it, where maybe you might have data in a cloud data warehouse. Popular choices are things like obviously like Snowflake, BigQuery, and Databricks are pretty common choices. But then you might have this long tail of systems like maybe production data in MySQL or in a Postgres, or some kind of like lakehouse, query engine, like maybe a Trino or a Presto, and maybe some time series databases. And then, increasingly you could have people running around and doing things on like laptops with DuckDB, and maybe moving that into the cloud with a hybrid architecture, like what Alex will talk about with MotherDuck. So the point being that there's just a lot more data sources out there that data engineers maybe have to consider than there used to be. And then at the same time, the analytics consumer has, really brought to the table a lot more applications as well. And these could be anything from embedded analytics apps. Maybe you're building customer-facing analytics and you're doing some kind of charting or visualization in your product as a part of the product suite. And maybe you're building that like in a React or an Angular or any number of frameworks. And you need to maybe marry the same data into an internal analytics situation with a BI tool. And this could be anything from traditional BI tools like your Tableaus and ThoughtSpots and Power BIs to maybe more modern things like Preset and Metabase come to mind. And then again, like I said, with the AI chatbots, I mean, this is sort of like a wild space with people building all sorts of things in LangChain and with different APIs from OpenAI right now. But the big idea is that being able to map all of these sources to their destinations and keeping things like access control and data modeling and query performance consistent is a real challenge for a lot of modern enterprises. And so, to get into maybe how Cube starts to solve some of that, Cube is a semantic layer product that sits in between the situation and provides four really main benefits. The first is a code-based data modeling experience that can be taken advantage of in JavaScript now or in YAML. And we recently released Python support with Jinja templating. So you can do some like very fancy kind of dynamic modeling things with these languages. And once you've got your data from the different data sources you're working with in a modeled format that you're happy with dimensions and measures and metrics defined, and all of your calculations consistent for your downstream users, you can then apply access control to all of these things. That is a sort of, I would say, really powerful role-based access control system. You can limit restrictions on what rows are visible. If you're doing a multi-tenancy situation, or maybe you're exposing one sort of large data set to multiple consumers, and you need to be able to, apply and enforce security filters. But you can also do things like column level masking. If you needed to maybe obscure portions of data for some users. And then in addition to that, we also provide a pre-aggregation and caching engine that we call Cube Store. This engine is aggregate aware. So when you've defined your aggregations inside Cube, you don't actually have to change anything about your downstream consumption. Cube is smart enough to do the query rewrites and to work out, if we have an aggregation that we can serve your query faster, we'll use that. If we miss, we'll go back to the database and serve you data out of like where the data lives. And then finally, everything leaves Cube via a GraphQL API or a REST API, which is more suitable for maybe these AI use cases or the embedded analytics use cases. And then as a SQL API that is a Postgres native dialect for anything that's more like BI centered or maybe where you just need to speak SQL. So to maybe drill in a little bit on like what kind of problems we're solving. A lot of times I think of like these sort of like six kind of like key benefits. Really with data consistency, we're achieving that through the access control and through data modeling aspects of the product, where we allow you to define consistent data modeling, consistent metrics that can be used between multiple BI tools, rather than maybe using the lightweight semantic layer that is built into a lot of BI applications. That, for instance, might get you a consistent metric calculation between, say, your Tableau, your ThoughtSpot, and then your embedded application that you also built. As well, with security, a lot of these BI tools also have their own models of access control, and keeping those consistent can be a challenge. And potentially, in the case of embedded analytics, be really challenging and something that, you just do not want to get wrong. You don't want to expose customer A's data to customer B in a multi-tenancy scenario. So that's something that we're really good at. And we address performance via the pre-aggregation engine. So, if you're working with a database or a warehouse that maybe doesn't do OLAP queries so well, Cube can be quite good at accelerating that. And then sort of these last points between, the flexibility of the stack, time to value, and future proofing. I think these are all general characteristics of implementing a semantic layer as a middleware between databases and applications. This lets you sort of evolve the stack more in a free-form way whenever you need to, because you can, swap one database out for another, and then you've got virtual data models in there, and with access control handled in a different layer, it's a little bit easier down the road to do that. So if you're still kind of not sure maybe where semantic layers fit in the modern data stack, if you are pretty familiar with the space, but you're saying to yourself, like, where exactly does a semantic layer go in my big diagram of boxes that I have to show my boss? We usually think of semantic layers being right between your warehouses or your different data sources and then the downstream tools. So, forgive the slide. We haven't added MotherDuck to it yet. There's a lot of text on it already, but you would see MotherDuck in that data warehouse category right there. And yeah, Cube Cloud just connects to that. And then, users can access data through Cube via the APIs that we'll talk about in the demo later. So yeah, I mean, with that, I've kind of got Cube out of the way, and I'd like to hand it over to Alex.
Well, thank you so much. Really excited to be here. Hi, I'm Alex Monahan. I'm a software engineer here at MotherDuck. So I wanted to start off with a quick poll so I could kind of customize a little bit about how we're chatting today. So quick, easy question. How much do you know about MotherDuck coming into today? So we'll give you just a couple seconds to answer that. All right, we'll do the Jeopardy theme music. Count it down just a little bit here. All right, well, thanks for taking the time to do that. We'll switch over and take a look at that. All right. Well, thank you so much for answering that. Glad to know a variety of you folks have heard about it. A couple of you have tried it, and some of you are active users, so fantastic. Well, got the whole gamut, and yeah, we'll tell you the story of MotherDuck. All right, so here at MotherDuck, we like to think of ourselves as a cloud data warehouse for the rest of us. So what would it look like if we targeted a cloud data warehouse at the sizes of data, the style of workload that the vast majority of people use, rather than what the world's largest tech companies use? So here I'm a forward deployed software engineer at MotherDuck, and I also work for DuckDB Labs. So briefly about me, I spent my background's industrial and systems engineering from Virginia Tech. So my fuzzy background here is maroon and orange for my crazy hokey colors. Then I spent 9 years at Intel. While I was there, we built an internal platform that used DuckDB. And I became a huge fan, one of the biggest fans on Twitter, and I got recruited by DuckDB Labs to do some documentation and blogging. And then 4 months ago, I joined MotherDuck. So now I get to do all DuckDB all the time. So I'll start kind of at a high level, then we'll kind of walk through the story of MotherDuck. So what is MotherDuck? Well, it fits into that cloud data warehouse bucket, as we looked at, and we're a serverless DuckDB platform. So what is DuckDB? DuckDB is an open source embedded analytics engine. So think of it as an amazing single player database. We call that the SQLite for analytics. So we're taking that single player experience and we're bringing it to the cloud for a multiplayer experience. Our goal is to be low cost and low latency, so both low cost and high performance. And we're focused on analytics. So we're not a transactional database, we're an analytical database. And part of our secret sauce is that we want to combine the power of your laptop with the power of the modern cloud. Because you might have seen the M3 launch this week.
Hey, Alex, I think we lost your sound there.
How's my audio? Better? Okay. Sorry about that, folks. All right. Well, let's see then. So the three things we want to talk about here today are really, why have we built MotherDuck? Why do we need to rethink the cloud data warehouse? And what has changed in the environment that make us think that this is worth doing? Secondly, what is MotherDuck? What have we built? What are we so excited about? And then third, once you have a tool like MotherDuck, what experiences become ducking awesome? So we love duck puns here. You can either be a duck-themed company and hide from it, or you could be a duck-themed company and jump right in. So brace yourself. We love our duck puns here. We also think that these experiences are really enhanced with Cube. So we'll talk a little bit about how they're very complementary and work very well together. So why rethink the cloud data warehouse? What has changed since cloud data warehouses were architected a decade ago? First of all, we truly believe that big data has been more marketing than reality. Computers have gotten a lot more powerful in the meantime. And it turns out, if you separate storage and compute, big data doesn't necessarily mean you need to be crunching all of that data every time. So we'll look at some details there. We also believe that laptops are powerful. Gone are the days of a 2-core laptop. You can have 16 cores that are quite powerful, and SSDs are quite fast. How can we take advantage of that? You've already paid for your laptop. It is 0 milliseconds away from you without network lag. How can we benefit there? Third, servers are enormous. You can rent a 400-core machine on AWS with 20 terabytes of RAM. There's not a lot of problems that can't fit in a box that big. How can we redesign and simplify the cloud data warehouse to take full advantage of these much beefier machines than when the prior generation of cloud data warehouses were architected? Lastly, we are huge DuckDB fans, and we think it's also popular in the industry. So we want to take advantage of that community in terms of giving back to that community, engaging with them, and not sacrificing the things we love about DuckDB while we build a cloud platform based on it. So looking at big data being dead. So the first kind of tenet of this, and these tenets they're hand-drawn graphs. They're based on the experience of members of our team who have worked at the major cloud database providers and have since come to help us build MotherDuck. In the data sets that they were seeing in those cloud data providers, there's a very select few companies that have all the data. So what would it look like if we built a product specifically for the vast majority of folks that aren't the top 10 biggest tech companies in the world? So to dive into that concretely, the data they were looking at BigQuery, 95% of customers had under 1 terabyte of data. That fits on my laptop. At SingleStore, 80% of customers were using the smallest instance size, and they were asking to go smaller because their data wasn't big enough to justify a larger instance. Gartner, most enterprise data warehouses are under 100 gigs. Andreessen Horowitz, if you're a B2B company, you tend to have under 1 terabyte. If you're B2C, you tend to have under 10 terabytes. So what would it look like if we could build something that's much more efficient at these levels of data? Not only that, because of the separation of storage and compute that we use at MotherDuck as well, even if you have to store a pretty sizable amount of data, most of it can sit there in storage and doesn't need to be computed all the time. So this is a hypothetical chart. So you see that nice little bump there for maybe your end of quarter metrics, another little bump there for when you're looking at your year over year comparisons. But data decays at a pretty rapid rate. Your click events from your website, if you've redesigned your website, that data is not quite as interpretable when you look at it a year from now. So most of your data is going to be sitting in storage and not computed every time. This is also a case where Cube is very helpful. Cube has the ability to process things ahead of time and also process things incrementally. So that way you're not in an interactive situation constantly recomputing on your old data. You're able to compute on it once and reuse that computation, reuse those results. Similarly, because of techniques like what you can use within Cube, workloads tend to use less data than you think. There is no fast and cheap way to have a dashboard look at 1 terabyte of data every time you go to the dashboard. That'd be a disaster, right? How many times do people click refresh on a dashboard? All the time. You don't want to be constantly looking at all of your data every time. So that means that with that separation of storage and compute, your compute needs are not nearly as large as the scale graph, exponential graphs would lead you to believe. The vast majority of workloads are under that 10 gigabyte size. How can we design for that? So we've made the case that we believe that big data has not lived up to the hype. What do we do now? Well, we need to make data easy. The analogy we like to use here is a hamburger. Most database researchers, most database companies are focused on making the best hamburger patty in the world. All their metrics on query response time. How long did it take to actually crunch it in the database? Well, it turns out bad lettuce, bad tomato can ruin a burger. Great burger is more than just beef. So this is where we lean into some of the benefits of DuckDB as well. It's got to be incredibly easy to set up and install. DuckDB has no dependencies. It can run anywhere. It can run in Python, R, Java. It runs with JDBC driver, ODBC driver for your favorite BI tools. It also can even run in your browser with WebAssembly. DuckDB can query data frames directly in Python with pandas, Apache Arrow data frames, as well as R data frames, even Julia data frames. And it is, we believe, the friendliest SQL syntax in the world. So really, making analytics easy becomes your design priority. And if your whole company is not focused on how do I scale more, how do I scale more, and focus on, for a given set of scale that most people need, let's put all of our time into making this delightful. Let's make this easy. I will mention as well, because of the semantic layer the Cube provides, you can choose when to use SQL and when to use dimensional modeling techniques and semantic modeling techniques like in Cube. So this is another area where we're very complementary. The API to MotherDuck, of course, is SQL, but it's frequently, if you're building a data application, that a different API is what you need, and Cube provides that. All right, our next tenet of why build MotherDuck. Why are we rethinking the data warehouse? Laptops are powerful, so let's move our data locally. To do that, DuckDB is going to actually take advantage of your DuckDB instance. MotherDuck will take advantage of your DuckDB instance running wherever you are and connect it to our server. So I want to take a look at a diagram here of what we call hybrid execution. So I want to start with just looking at kind of the big squares, your local DuckDB and your MotherDuck server. So when you connect to MotherDuck, you're using the open source DuckDB driver. Every DuckDB driver actually has the entire database engine inside of it. Pretty neat. It's a lot like SQLite in that way. When you use a JDBC driver on most databases, it's just a connection protocol. For DuckDB, it has the whole engine right in there. And so that means that wherever you connect to DuckDB, you have the ability to run DuckDB right there. So we're taking full advantage of that. You can submit a single SQL query, and MotherDuck is actually going to automatically determine what should run locally and what should run in the cloud. So in this example, we're going to submit a SQL query, and we're going to go ahead and decide what to do locally, right where you are, typically on your laptop. And we're going to do that by pulling down where your tables are from the server. So we'll cache our catalog, and we're going to figure out, okay, in this query, you're querying some cloud data. So we'll move into the execute phase, and we will send this query plan over to the server and say, hey, I'm interested in these tables. This is my SQL query that I want to run. It'll pull the cloud data and send you back the results. And this is a more traditional way of doing things. One advantage, though, is that we are doing that parsing step locally. So that's faster there, and it also reduces the amount of load on our cloud. The real magic, though, gets to where you can do a local query. Because we have that catalog already stored locally, we can actually read your SQL, decide what action needs to be taken, and if all your data is local, we can execute it immediately and get you the results very, very quickly. This is very common if, let's say, you just did the previous slide. You pulled down a result set and you cached it locally. Now you want to slice it, you want to dice it, you want to group it, pivot it, summarize it. All of those follow-up slices and dices are going to be entirely local and entirely instant. Plus, it's running wherever that local DuckDB is, so it will be, in all likelihood, free. One additional case, additional magic, is that one SQL query can run partially in both places. So you can really have the best of both worlds. We're actually going to dynamically decide, should we upload this data to the cloud and join it in the cloud? Or should we download this data from the cloud and join it on the client? And we can make many of those decisions within the same SQL query. So this is very powerful. You get the best of your local, which is use the CPU you already have, no network latency, but you also have compute resources that can be bigger and larger in the cloud and right next to your cloud storage that you might already be using, like Amazon S3. So that's how we're taking advantage of your local compute with MotherDuck. Our next tenet is really that servers are enormous. So what action do we take based on that? Well, let's scale up instead of scaling out. As kind of a case study here, there was a research paper published by Google in 2010 that really changed the way people thought about and designed distributed systems. It's the Dremel paper, Interactive Analysis of Web Scale Datasets. And in 2010, that Dremel example ran on 3,000 nodes. So let's compare the total processing power available on those 3,000 nodes with one machine you can rent on AWS today. With 128 cores, a terabyte of RAM that only costs you $11 an hour. So if we look at the chart, we have many more times compute power. We have many multiples of the RAM. The SSD size and the RAM bandwidth are both much higher, and even our SSD bandwidth is higher on this single machine. The only case where one machine is not equivalent to 3,000 is with the bandwidth going back to object storage. And this story is about to change. They're launching 800 gigabit per second Ethernet connectivity in the cloud, and that's going to solve the last remaining problem to make one machine of the current day equal to 3,000 when the current generation of cloud data warehouses were being architected. So if one machine is the same as 3,000, what would we do differently? Well, we would scale up. We would get one big beefy machine per individual user of MotherDuck. So you're actually going to get an allocation of one really big beefy machine, whichever size slice that you need. And that way, the computations, the algorithms can be much more efficient than having to send a message out to 3,000 servers, get the answer back. Oh, sorry, 2 of those failed. Okay, I need a rerun on that, so now I have more delay. Running all on one machine has significant efficiency benefits, and that can be speed and cost efficiency. Okay, if everyone loves DuckDB, well, let's supercharge it. So I have one more poll for you. If you wouldn't mind taking a quick look, this is another quick question. How familiar are you with DuckDB, the key ingredient of MotherDuck? All right, we'll give it another just a few seconds here. All right. Let's take a look then. Fantastic. Most folks have heard about DuckDB. A couple of folks where it's new. Fantastic. Glad to get to show you it. I'm a big fan, have been for a couple years now. And a couple folks are actively using DuckDB. Fantastic. Well, thank you for that. So if I had to summarize DuckDB, what is DuckDB? Well, DuckDB is a lightweight, in-process SQL analytics engine, the SQLite for analytics. And we think it's really taking the data world by storm. So here's a look at the DuckDB website, and they do a pretty good job of breaking down the best things about DuckDB. The wording, DuckDB is an in-process SQL OLAP database management system, is a little bit tough, but that's where we think of it as the SQLite for analytics. That analogy really helps. The in-process nature helps with the simplicity. It means there is not a separate server for you to manage. It happens right in your application. So instead of doing something like import pandas, you could import DuckDB. It has no dependencies, and it's pre-compiled for a variety of platforms, so it can be as easy as a pip install, and you'll be ready in a couple of seconds with no dependencies. And it has APIs in a variety of languages now, Go, Rust, as well as your traditional Python, R, Java. It's very feature-rich. So there are some engines that say, we're SQL compatible, but the SQL they're compatible with is the 1992 version or the 1999 version, which is decades old at this point. DuckDB is on the leading, bleeding edge of having all of the tips and tricks available for you in SQL, so you can really manipulate your data as precisely as you want. And it's also designed to be friendlier. So that way, it's very flexible with case sensitivity. If there's an error, it tells you exactly where it happened in the query. And it also has some very nice features about reading Parquet files, writing Parquet files. So it's much more than a basic SQL dialect. It's very flexible. It's also designed to be very fast. It's using all the modern research techniques. It's a vectorized engine, which is similar to all the cloud data warehouses. And it's designed for bulk queries, analytical queries, where you really need to analyze those trends. It also does things in parallel across all your CPU cores, and that's how you can scale up, is you have to take full advantage of all the cores on the CPU that you're running on. And DuckDB is MIT licensed, so you can, that's one thing you could take away from today for sure, is that you can go try DuckDB out for free anytime, wherever you are. It's open source. We're also very excited about DuckDB because of the pace of innovation. They're improving at an incredible cadence, and we're seeing a lot of folks interested in it. So this is the GitHub star history. We love that exponential shape of that curve. So we're excited to be an extension of DuckDB, where as DuckDB is improved, MotherDuck is along for the ride as well. And we are contributing to that as well. This is another way to look at it. This is more from the database perspective. DuckDB is one of the fastest growing databases in the database engines ranking. This is a logarithmic scale. So even though it looks like it's tapering, it's actually still growing quite quickly. All right, so this is another way to think about MotherDuck. Now that we've looked at the key ingredient DuckDB, we are that serverless platform, and our aim is to be low cost and low friction. But that being said, DuckDB is a single player application. We want to be able to scale to handle more complex apps and larger data set sizes. So if I had to compare and contrast DuckDB a little bit with MotherDuck, DuckDB turns your laptop into a personal analytics engine. And we know that laptops can be pretty powerful these days. And MotherDuck is going to scale that into the cloud, but still use your local compute with that hybrid capability. DuckDB is designed to be incredibly simple for development and prototyping, with both local data and data pulled from cloud object stores. And MotherDuck allows you to move into production. And frequently that is as simple as changing a configuration. That's something that we've seen people do with DuckDB, even with the current cloud data warehouses. So for example, people will actually run they'll take their cloud data warehouse queries, they will transpile them into DuckDB syntax, they'll run them locally on DuckDB to test them out, and then they'll rerun them on their cloud platform. Well, what if it was all the same SQL? What if it was all the same SQL engine? And your local testing could be guaranteed to work in the cloud as well. And how can we make that a really smooth deployment experience? So DuckDB is an embedded database. Another word for that is in process. It's worth noting that in process is not the same as in memory. So it can definitely handle larger data sets than your RAM. But MotherDuck is then taking that to make it a collaborative environment where it's serverless. We're going to spin up whatever compute you need on demand. And we are a platform that is powered by DuckDB. So now that we have built this system that is this hybrid system, this cloud platform based around the fantastic DuckDB engine, what becomes ducking awesome? What experiences change? How does your work meaningfully get easier? The first thing that we think gets a lot easier is data exploration. This comes back to that hybrid execution, but it also relates to the fact that we are targeting very low latency with our architecture. Because we don't have to manage 3,000 machines every single query, you can get an answer back in a sub-second time frame, rather than always having to wait at least a few seconds even for the simplest of queries. This really kicks into high gear though once you have a result set cached locally. Then your data exploration can be as fast as you can click or faster. 24 frames a second of data exploration and manipulation. How much more delighted would you be exploring a dashboard, or would your executive be exploring a dashboard, or maybe even your customers using your custom web app that you're developing to provide them analytics on their data? How much more delighted would they be if their exploration were instant? Secondly, we really think we can change the experience of being a data team and allow local development on a data team to feel much more like local development on a software team, where you can truly test your data pipelines locally on your laptop. That is within your control, it's your local environment, but also it's free and very powerful. And once you like what you have, you can push to the cloud. Another key aspect of this is CI/CD. If your CI/CD is always hammering your cloud data warehouse, that gets expensive fast. So you're not going to set up thousands of tests in your CI/CD like a software team might, because you just can't afford it. It would take too long. With DuckDB, you can have a powerful CI/CD workflow using the open source DuckDB. And then once your code passes all those tests, you can then change that configuration and deploy to the cloud. Thirdly, data apps are a use case where MotherDuck really shines, especially in collaboration with Cube. We believe that by designing for latency, that data apps can really be a dramatically better experience. As a part of building these data apps, though, you're not always going to want SQL as your API. So we're very excited about Cube's REST API, Cube's GraphQL API, as well as their data modeling capabilities, because you can build your apps faster using those tools. So we think that the MotherDuck engine can really provide that speed, that scale, and that high interactivity. And then Cube is also going to provide that developer experience of making it easy and fast for the developer to build, for the data folks to build. So thank you very much for coming on this journey with me here, learning about MotherDuck. Now we're going to jump into a demo. And as you have questions, feel free to type those in. We will get to those here before too long. So we appreciate your questions. All right. Looks like my screen is there. So I am here on my instance of Cube Cloud set up for MotherDuck. And I'm here looking at all of my deployments. So I want to show, to start with, how easy it is to go ahead and create a MotherDuck deployment on the Cube Cloud. And then we're going to jump into one that we've built ahead of time with some modeling there. And then I'm going to turn it back over to take a look at an app that we've actually built based on this. So to start with, if I wanted to connect Cube to MotherDuck, I'll go ahead and create a new deployment. And I can name this anything I'd like. We'll call it Doing It Live. And you can pick whichever cloud platform you'd like. MotherDuck is on AWS, and we are in US East 1 right now. We plan to be multi-region before long, but this is going to be the best place to go for lower latency for the moment. I am going to go ahead and create a fresh deployment. I could import it from elsewhere, but I want to show what it would look like to do it directly. So we're going to create a fresh deployment. And now we have a DuckDB connector here that we can choose. This goes back to our idea that to connect to MotherDuck, all you need to do is use a DuckDB driver and change the connection string. So the connection string is going to be MD : or MotherDuck : and your DuckDB driver is going to then be turbocharged by the MotherDuck extension. So we will connect to MotherDuck using DuckDB. Here we're going to go ahead and use a MotherDuck token. So let me go ahead and show you the MotherDuck UI briefly so we can get that token. So because DuckDB can run anywhere, even in your browser, here at MotherDuck we've built a browser experience for interacting with MotherDuck. And it also has the full power of DuckDB in your browser. So it's a notebook-like experience where you can explore your data, you can run your queries, and then once you've run your queries, you can go ahead and do subsequent processing and follow up on them. So if I wanted to sort or filter, I can even do some subtotaling and pivoting. All that can be done locally, so it's instant. So your follow-up analyses are really very quick. I'm going to go ahead and grab my token here, which is my service token. This is unique to my user. And that's what's going to allow me to go ahead and log into MotherDuck through Cube. All right. We also have some optional parameters here. MotherDuck and DuckDB have the ability to pull directly from Amazon S3. You can pull CSV files, JSON files, Parquet files even hold directories of those. So you can say, look at a partitioned set of Parquet files, and you can pull it straight in and query it directly. You can either query it directly on the fly, or you can actually insert it into MotherDuck as well. So we will not be doing that just here, but you can easily, that's a great way to get started, especially if your data is already on S3. And this is compatible with more than just Amazon. So you could do this on GCS, Cloudflare as well. You may want to choose a different deployment target in the first step. So I'm going to go ahead and apply. It's testing our connection here to MotherDuck. And it was successful. Fantastic. So what Cube's going to do now is it's going to go ahead and allow us to choose some tables that we want to then do some semantic modeling of. I'm going to pick one for our example here. This is some rideshare data. So you can think some Uber data from New York City. And let's go ahead and see what Cube is going to do automatically on my behalf. It's actually going to automatically deduce whether a column is a measure or a dimension. It's going to also go ahead and figure out kind of the type of data that we're dealing with. These checkboxes here are whether or not we want to pull the data in. So I'm just going to go ahead and pull it all in for our demo here. And we can see that the vast majority of these have guessed exactly what I'd like. You know, things like tips, things like tolls, those are measures. And that's looking very good. I will choose, these location IDs, for example, we can change those to dimensions because those are actually, ID codes rather than meaningful numbers. And it's automatically moved those to string, which is going to be perfect. So as easy as that. That's that is already a huge step on the way to dimensional modeling. Very automatic. Here then I get to choose my primary key. And in this case, we're looking at a single table, so we don't need to join, but we can actually set up those relationships here if we need. And then we get a nice summary of where we are, and we can choose if we prefer JavaScript or YAML when we deploy. And that's all there is to it. This is going to go ahead and build an environment for you in Cube that is connected to MotherDuck. So this does take just a moment, just the first time that you build it. Every other time it's much faster. So what we'll do is we'll hop back to one that we have built ahead of time. So here we are at our deployment once it has fully completed. And you can see right away that we have easy access to both a REST API and a GraphQL API. And we'll see how to take advantage of that a little bit later. So immediately we already get some real nice benefits. If we're not super big SQL folks, we're already able to use whichever API we're comfortable with. Part of the key, one of the real good places to start, is the data model itself. So in this case, this is something we've modified a little bit, but by and large, this is mostly generated by that UI we just went through. So you can see very similar things we just looked at. We can see what are our dimensions, and then what are our measures, as well as kind of the data types and the SQL used to generate it. And we can do things like add additional capabilities wherever we need to. And in this case, we can drop back into SQL seamlessly for small snippets. So rather than building a really big, giant, hairy SQL statement, SQL can often be very good for expressing your intent for very small targeted things. So in this case, it's a case when statement of whenever there's an airport fee, well, then I want to label this particular trip that someone took as an airport trip. So simple to express in SQL, and we can go ahead and build an additional dimension based on that. Likewise, we can also build complex metrics. So we can do things like create an average that will always recalculate on the fly, depending on whatever we are looking at. So it's actually going to recalculate the average by doing the sum and dividing by the count. If you've had to do this in SQL at multiple levels of granularity, you probably enjoyed it about as much as I did, which is not a lot. You've got to do this many, many different ways, many, many different times. Calculating averages on the fly is just one of those things that come up everywhere, but is a pain in SQL. And that is not a pain here in Cube. As a note, I started using Cube last week. I found it great to get started with. I'm basically, I know a couple languages, but I'm a big SQL fan, and this felt very comfortable for me. And I could also see places where it immediately made it easier than SQL for me. So big fan already. And this we'll get to here a little bit later. Cube also has some powerful pre-aggregation capability. This is, again, based on the idea that if you have many, many users of a dashboard, you don't want them all rerunning the calculation all at the same time. There's limited benefit in most cases. So how can we calculate it on a regular cadence? How can we incrementally calculate it such that we don't have to recalculate things we already know? And that's a significant savings both in time and money, but also the experience is far more delightful. So as I'm editing my data model, I also have a playground that I can use to go ahead and experiment with and explore this data as I'm building this model. So we've done a couple of queries here that we can run on MotherDuck. I will rerun. Fantastic. So we can see here that the query was accelerated with pre-aggregation. So this means that this lightning fast speed is because we are able to use Cube's caching capabilities with the pre-aggregation. Part of what makes MotherDuck and Cube a very good combination is that if you have a really complex SQL statement that you need to rerun every time, frequently this can be something like a percentile or a quantile or some kind of rolling average where you really need to recompute over your data. That's still going to be very, very fast because of MotherDuck's analytical capabilities and our low latency. However, caching the data is always going to be faster. And Cube offers some flexible ways to do that. So if you are able to cache your data for a period of time or run it on a regular schedule, you get this kind of lightning experience from Cube. So here we can also explore it with a chart. And this shows the difference between if you took an airport trip or not, how far were you going? You can see that the 0, which is you were not taking an airport trip, is typically a lot shorter than a trip going to the airport. And we can also look at a variety of other ways to slice this. How excited are folks to tip based on whether or not it was an airport trip. So we can see a 1 versus a 0 here, that people do tip more if they are going to the airport. And we've got a couple other different ways to slice it and dice it. So this was all something that I'm getting used to this week, but it was something that I was able to get up and running with really quickly and really get both a combination of the nice speed of MotherDuck and the nice speed of the Cube caching layer. So with that, I'd like to go ahead and turn it back over. Thank you for your attention.
Yeah, thanks, Alex. I'll go ahead and share up my screen. We'll continue on with the demo. Let me get my screen shared. Awesome. What we're going to do is take the next step then. So we got our data in Cube, and Alex mentioned the APIs. How do we get our data out of there? One of the big reasons to use Cube is to get that accelerated experience for embedded applications. And so one of the things that Cube does really well is it kind of builds those for you. So for example, here's a chart in the playground, which Alex was a different chart, but it's same playground experience. And we've got a few different libraries here as far as creating those embedded analytics. So I'm going to pick React and then recharts, for example. We've got our chart that generates here. It's generating off of our pre-aggregation. But then we can also see the code to drop this in as a React component. And it gets pretty detailed into all the styling that's used to create that chart. It's got our API token and our API URL. It's all built in right there. So what we can do really quickly with the combination of MotherDuck and Cube is to create something like a React app where all those data points are brought in from Cube or accelerated by Cube and available through that REST API. And so what we have from the React component standpoint, I've just got each of those charts that you saw on the previous screen is its own React component, and with very, very minimal modification. Each of these files is just that code from the playground. So really nice to be able to just plop that in and do some light customization, and then I've got my chart here. The other thing that we can do that's really powerful is to introduce access control and row level security. So for your embedded apps, maybe we want to make this dashboard available for each of our different dispatchers. So maybe this is an organization ID, and each one should only see their own data. So we can build that into Cube in our data model. Everything's under source control in Cube. So we've got we have a query rewrite function that's going to take a look at our security context. And if our security context is admin, which is a kind of a protected or a global can see everything permission, then it's going to go ahead and show us all the data. But otherwise, if it's not admin, it's going to filter that dispatching base num based on whatever is in the security context for the org. So what does that mean? So let's go into the playground. So in our security context here, we have an org. And then in this case, our org is B02870, which is one of these ride shares or one of those dispatchers. So when we save that and we run that, we see that our data is filtered for that security context. If we edit this to admin and we save and run it, we see the data changes because we have more access to more data. So we can actually generate these the API keys or the JOT tokens that we need in React, or we can generate them here in the playground. So I'm going to actually pop over to our new playground in our security context builder. So here's org admin, and if I copy this key out, that's going to be the key that's a combination of the API access key that's within Cube and this JSON string. So if I want to change this, maybe you saw that it was pretty quick, but maybe you saw the token update. So I can copy that token, and then you notice my React app, I've got 91 million trip miles, and I've got access to see all my dispatcher stats here. But if I go into VS Code in my login component, you should not hard code these in production, but just for the sake of example, I'm going to put that code in there, comment that line, comment out my old admin security JOT token, and then we'll pop back to the app. And when we refresh this, we should see we are now filtered to that to just that one dispatcher. So it's a great way to provide row level security and access control on top of DuckDB data. Again, this is all pre-aggregated, so it's accelerated quite a bit, but it's as Alex mentioned, it's a great way to to make your initial dashboard. Maybe you do some pre-aggregations on the most common or the kind of the homepage dashboard that folks will be seeing. That way those queries are fast. And then as they start to drill in, the data selection sizes will get smaller. Maybe the analytics will get more complicated, and it's not something that you want to run or pre-aggregate. You don't want to boil the ocean with your pre-aggregations, but MotherDuck's going to let you run those queries in their fast analytics engine. So it's a great backup when we start to exceed the capacity of the what we want to cache in Cube. So I think that's just about it. Other than we've got the ability to look in query history, see what our queries run at. So we can see things like when we've pre-aggregated in Cube Store, we get a different color indicator than if we run those queries directly back to MotherDuck. So we have the ability to see what's fast, what's slow. Maybe we want to add a pre-aggregation here so that way those particular queries run faster. But we've got the analytics here to help us make that decision. So I think that's about it. So I'll go ahead and turn it over to Brian for our Q&A. I think we've got a number of different questions that have run in. So yeah.
Yeah, thanks. Thanks to both Alex and Tony for taking us through, not just the demo, but also a explanation of, what MotherDuck is and what DuckDB is for anybody who's not familiar. Yeah, as Tony said, we do have a little bit of time left for QA, and we had a number of questions come in. So we're going to go ahead and start working through some of those. And if you have any other questions about what was presented today, or about MotherDuck, or about Cube, go ahead and get them in the QA, and we'll try to answer them for you. So I guess first, we've got a question from the audience, and the writer asks, is it possible to deploy DuckDB and Cube on Kubernetes? So Alex, do you want to tell us about the DuckDB story here?
Sure. So DuckDB can run anywhere, and we are deploying it on our servers as well. So Kubernetes is a part of our infrastructure there, so it definitely does do that. Part of the value of MotherDuck is that we're a software as a service, where you don't necessarily have to manage your own Kubernetes, don't have to manage DuckDB. But if you do want to self-manage and kind of own that end to end, that is very possible.
Yeah, same story with Cube. The product that we showed today is Cube Cloud, which is our commercial software as a service offering. There is what we call Cube Core or Cube Open Source. So you can of course run that however you'd like. Normally does require some DevOps experience running it on Kubernetes yourself, and of course we use Kubernetes internally, when we provision our own kind of cloud products. So yeah, that's the answer from the Cube side. Next question is, the writer asks, so is MotherDuck the data storage backend, or does this work in conjunction with something like Databricks, et cetera? Yeah, Alex, I know that you guys have some capabilities to ingest data, but also the platform's quite different. So if you wanted to run us through maybe both of those things.
Sure. So MotherDuck definitely has its own internal storage, so you can definitely store your data there. We're in the process of adding some nice features like time travel, where you can go ahead and look back and see what your data used to be recently. You can pull data from object storage, so that object storage can be on AWS, GCP, or Azure, and it can be Parquet files or Iceberg. We just are adding Iceberg support here imminently. So that is a good way. Some other platforms do allow you to save to external storage, and then we could consume from that external storage. So there is a way for us to ingest from other places that you already have your data.
Yeah, no, that makes sense. And I think that's a really interesting distinction. I know people have a lot of questions about exactly how how the platforms all work together. I guess one thing that we didn't really talk about as much with Cube was when we implemented DuckDB in our own product, that gave us the native ability to connect to CSV, to Parquet from an object store, which we actually didn't have before. Before, if you wanted to do that, you would have had to maybe spin up another external query engine or load it into a database or something like that. So not only did we partner with MotherDuck to provide connectivity to the MotherDuck platform, but we also run an embedded version of DuckDB as well to enable some functionality within Cube Cloud.
You bet. And yes, that can go directly out to S3 as well. So that's another option too, just the native DuckDB connector on Cube.
Yeah, so let's see. Okay, one more. This is kind of a little bit complicated question, but I'm going to try to take it apart here. The viewer asks, can DuckDB replace tools like dbt to reduce the complexity of data pipelines? And the example they give is, downloading raw data and then loading it into DuckDB, then cleaning it, transforming it, and querying it, and then storing it back to Parquet. It's kind of a multi-part question, so maybe we'll stop there and maybe let Alex kind of give his thoughts on that use case.
Sure. So we're kind of building the foundational data warehousing style layer, which means you can kind of use us in a variety of different ways. We actually have a dbt adapter. It actually is the example. The DuckDB dbt adapter is the example from dbt Labs. So if you go ahead and download their Joffle Shop example, you're going to be using DuckDB right out of the box. And to convert that to MotherDuck is to change your connection string. It's really that easy. So there's a very easy path to use dbt with DuckDB as the engine, as well as MotherDuck as the engine. That being said, we are a full SQL engine. So if you prefer another tool outside of dbt, you could do everything in Python with some of the data frame type of libraries that execute SQL underneath. So you could use IBIS, you could use Ponder, all kinds of different APIs that you can use, as long as it reaches SQL by the time it hits MotherDuck. So likewise, the Cube ability to do that, with the GraphQL side, with the REST side, it's going to get translated to SQL before it hits us, but however you'd like to get that SQL to us is up to you.
Yeah, and our view on transformation is that the Cube is not a data transformation tool, but there's sort of like some, I would say, discussion on like where transformation sort of ends and like where semantic modeling begins, right? And like what is like the last mile of data transformation? And the way I sort of think about that question is, in ETL tools, you're typically doing like the rougher grained type transformations, like you're maybe moving data from sources to intermediary staging, you're maybe reshaping or pivoting or doing like large scale transformation. And then a lot of like what Alex showed in the modeling inside Cube is kind of what we think of as, really like metric definition and, applying some dimensional rewrites or some measure, things like scalar calculations that are like easy to do, or like derived metrics, or maybe doing ratios that are like harder to express, doing it in like raw transformation. So that's kind of a distinction. I mean, a lot of people ask that question, about like where transformation sort of stops and like where what we do sort of begins. So it's maybe worth kind of like recapping that there.
And I'll jump in just from my experience as well. I mean, doing all of that with just in the transformation layer, just in the SQL layer, is going to be painful. Cube has tremendous value, especially in those kind of metric calculations of, doing ratios on every level of aggregation in your data that your user could want to explore. It's miserable. Cube is going to make your life way better, and there's always going to be a place where you're going to want that semantic model.
We appreciate the vote of confidence there. We have a couple more. There's one that I feel like is a pretty ambitious question. I'm going to go ahead and ask it because I think it's kind of funny. We had a user ask, would Cube together with DuckDB be able to replace services like Datadog? Example, ingest data to S3 and Parquet files, then ingest the DuckDB, then analyze with Cube. I'm going to say, like, if you think about these like Datadog and Splunk both, there is a lot of, the actual event collection and the log collection and ingestion that obviously we don't do. You'd have to build those things. But if you start to think about like core processing, you could probably do some of that for sure.
Sure. So we are actually exploring the pattern because DuckDB can run anywhere. We're exploring running it at the edge and having it be the agent that is collecting those logs. And maybe you can reduce them before you send it to your central platform. So we do actually think there's a log analytics use case for DuckDB in combination with MotherDuck as well, because you'll want to reduce the data as much as you can at the edge. And you will still want to analyze it all together at some point. But what if your data reduction language could be SQL instead of having to go learn Logstash from the Elk stack, for example? So we're excited about that pattern. We're in the early days of exploring it, but stay tuned. DuckDB is a great thing to fit SQL anywhere you need it.
Yeah. looks like we're right at time. So I'm gonna answer one more question here. We had a viewer ask, which category of tools does Cube see itself in? Which other tools does Cube see as competitors? Yeah, at Cube, we say that we're building a universal semantic layer, and the distinction that we make with the universal portion of it is that we're not overly aligned to any outside warehouse vendor or to any analytics vendor. So our objective really is like true universal interoperability between as many different databases as we can, as many downstream experiences as we can, and providing really a first-class SQL API and GraphQL and REST API experience for that, just to make sure that, really, fundamentally, we believe that developers are very clever and they should kind of have their own choice of whatever tools they want to use, and we just want to empower that as much as we can. Yeah, so as far as competition, usual suspects, I would say, like we run into guys like AtScale, obviously DBT with their re-released semantic layer. Yeah, sort of where you find ourselves. Cool. Well, looks like we're at time. So I'm going to go ahead and move this over to the webinar resources here. And Nathan, if you want to play us out.
Absolutely. Thank you, Alex, Brian, and Tony. Super insightful and informative. If you all want to check out these resources, both for Cube and MotherDuck, this will direct you to everything about our integration, as well as our community, both in Cube and MotherDuck. So thanks for joining. Continue to join us for other webinars in the future. But have a great day, everybody. Bye.
Thank you, folks. It's been a pleasure.